Kaboom!
Boom! Okay, 5.5. We're still factoring, and what we're factoring is trinomial squares. Factoring. Okay. We're factoring trinomial squares. And we're also going to be factoring difference of squares, but I'll write that down when we do it. Okay, a trinomial square, what it's talking about is when it ends up being like 3x plus 2 squared would be your answer. This is going to end up being the answer, okay? If you had 3x plus 2 times 3x plus 2. Let's go ahead and FOIL it out and look what it would look like. You got 3x plus 2 times 3x plus 2. To multiply it out, you do the first times the first. So what is that? 3x, what is it? 9x?
9x squared.
9x squared, okay. And then
6x.
plus 6x. And then the middle term here,
Plus 6x.
plus 6x again. You're going to see that that happens all the time right there.
And plus 6x.
And then, yeah, it's going to be the same thing twice here.
4.
Okay, and then 2 times 2,
Plus 4.
plus 4. Okay, the middle term, plus 6 plus 6,
Cancels out.
doesn't cancel.
12.
12x. And the 4 comes down, and 9x squared comes down. Okay, what you're going to be doing is going from this back to the 3x plus 2 squared. Okay, so what you're going to do, this term here will be, you'll have the square root of it. The square root of 9 is 3, square root of x squared is x. So what you do is you do the square root of that for your first term. So that's how you get the 3x there. The 4, the square root of that is 2. That's where you get the 2. Okay, the way you recognize that this is one of our perfect square terms here, this middle term here, 12, will be this number times this number times 2. So you see this is 2 times 3. Remember when we multiplied it, we had plus 6 and then plus 6 again? So when you have this 6 here and you see that that's doubled, you know this is one of our square terms. This is a perfect square. And it's got to have the plus here to be a perfect square. I'm going to do another one here and we'll be able to look at it and see, well, is it one of these? How about if we have 9x squared minus 12x and then a plus 4. Okay. We already know that this would be 3x, and that would be 2. Okay, 2 times 3 is 6. Double 6 is 12. But we need a negative 12. If we put a negative 2 here, a negative 2 times 3, negative 2 times 3 is negative 6. When you double it, you get negative 12, right? So this one, this is the correct factorization of this one. But you have to have a plus right here. Because when you're multiplying it out, FOILing it, when you're doing this up here, it has to be either like negative 2 times negative 2 or positive times positive. Because remember, it ends up being the same thing times itself. So your very last term has to be positive. Because it's always going to be this times itself for the last term. If this was negative, it would not be one of these. Okay? So you have to have the plus here, or it won't work. The minus here is going to tell you, right here, you're going to have to put a negative inside here.
So why is it power 2 then?
Because it's times itself. This right here means the answer is 3x minus 2 times 3x minus 2. Maybe I should have done this first and then put the squared because it's times itself. That would have probably been better.
So they're all going to be 2 then?
That's the type of problem we're working on right now, yes. Let's do another one. Let's do some so you can kind of recognize them a little bit. Let's do one that's simpler. Let's do one, x squared plus 6x plus 9. Okay, we got a plus 9 here. So it could be one of these perfect ones, okay? What we're going to do is factor the way we normally factored then, instead of jumping into the, see if it's a squared or not. The x squared would be x times x, right? How do we get 9? 3 times 3. This could be it, right? 3 times 3. If we double the 3, it's 6, right? So this is one of these perfect ones. If we put plus 3, we have plus 3x plus 3x. That gives us our middle term. So this is one of our perfect squares where it's just x plus 3 squared, because it's the same thing times itself. Let's do some more easy ones. What's so funny? That wasn't easy?
No, that was easy.
Okay. What if you have one that has the x term last? What are we going to do? Before you start factoring, what do we got to make sure we have here?
A positive?
Look at our x's.
Oh, combined.
We want to make sure that the x's are in descending order. See, here we had x squared, and then we had an x term and then a number. You want to always make sure they're either going up or going down. Here you have an x squared and then a number, then an x. So first, let's put them in order. So we'll just put this in the middle and put the 49 at the end. We're just going to rearrange them. Minus 14x and plus 49. Okay, the square root of 49, 7. Is 7 when you double it, is that 14?
Yeah.
Okay, this is going to be one of those then. So we're going to have the x and the x, and we're going to use the 7 and the 7. And what sign are we going to put here?
Negative.
On both of them, right? They're both negative. That makes negative 7x, negative 7x. And a positive 49 is because we have negative 7 times negative 7. So this is x minus 7 squared. So even if you don't recognize it as a perfect, you know, the squared thing, just do it like you're normally factoring it anyway. See if the 7 times 7 will work. If it doesn't, you can go back to like 1 times 49 or whatever. Okay, let's do another one. X to the 4th plus 20x squared plus 100. Okay, there's not x's everywhere, so you don't factor an x out, right? There's nothing you can factor out. So let's try doing this. X to the 4th, what would we put here? X what?
Square.
X squared, because x squared times x squared will give you x to the 4th. Okay, what's the square root of one
It's
hundred?
shrinking the
Okay.